Alright guys, this is lesson 6.2. This is the fourth video. This is one I was going to put online and then I ran out of time, but at least you can watch it in class. And these will be just a couple really tricky things now when it comes to solving these trig equations. So let's take a look at this one. We have cosine squared equals sine squared plus 1. And the thing you notice about this one, and I realize I skipped number 8 and that's okay, but the thing you realize about this trig equation that's different to some of these other ones is the other ones had one trig function in them. Here's sine squared, and here's sine. The fifth one didn't matter because it was factored, but the next one is sine squared and sine, or the next one, sine to the fourth and sine squared. And even that one we're skipping was cosine squared and cosine. So what makes this one different is you've got a sine squared and a cosine squared in it. And if we're going to factor this, we have to get it down to a single trig function. So we have to use some of our trig identities, and with those identities, get it down to one trig function. And hopefully when you see those squares, immediately you're thinking, wait, sine squared plus cosine squared equals 1. And then take your pick. Do you want to sub out the cosine or the sine? It doesn't really matter. I'm going to come over here and solve for cosine. So cosine squared of x is 1 minus sine squared of x. And so I'll come back over here and I'll sub that in. For cosine, I'll put in 1 minus sine squared of x equals sine squared of x plus 1. So you want to get it down to a single trig function. Once you're there, get your sines on one side. So add sine squared to both sides. And I've got 1 equals 2 sine squared of x plus 1. I'll subtract the 1 and look, you get 0 equals 2 sine squared of x. Divide by 2, and I still get 0. Raise that up a little bit. Hopefully you can see that better. Not there. Divide by 2. I'll get 0 equals sine squared of x. Take the square root, and you still get 0 equals the sine of x. And then look for that in your unit circle. Where does the sine equal 0? And hopefully you find two spots that equals 0 at 0 and at pi, because sine, and you could say 2 pi. But typically, since we said 0, that's the same thing as 2 pi. And hopefully you found those on your unit circle. So where's the y-coordinate? Where's the sine 0? It's 0 and 2 pi. So if they give you some equation that's not factored, and there's multiple trig functions in it, use some of your identities to get it down to a single trig function. So let's look at one more of those, and I'll talk about a couple that show up in the book. Cosecant squared minus 2 cotangent equals 0. All right. Do you know the identity 1 plus cotangent squared equals cosecant squared? If you do, use that. So cosecant squared is 1 plus cotangent squared minus 2 cotangent of x equals 0. Let's put this in descending order. So I'll put the cotangent squared first, minus the 2 cotangent of x plus the 1 equals 0. Now we need to factor this. We look at the last term, it's a 1. How do you break up a 1? Not many possibilities. 1 times 1, or negative 1 times negative 1. We'll go with that one, because negative 1 plus negative 1 is negative 2, which is our middle term over here. So just to show my work, you can do this quicker than I'm doing it, and that's okay. Cotangent squared of x minus 1 cotangent of x minus 1 cotangent of x plus 1 equals 0. So I split up that middle. The first two, what do they have in common? Cotangent of x. Bring that out. And I get cotangent of x minus 1. Second two, what do they have in common? Not a whole lot. I'll factor out the negative 1. And I'll get cotangent of x minus 1 equals 0. And now look at those two. That's the same. So I bring that out. Cotangent of x minus 1. What's left? Cotangent of x minus 1. Oh, I get the same thing twice. So cotangent of x minus 1. Again, this equals 0. How do I set something equal to 0? Well, either the first term equals 0 or the second term equals 0. They're the same thing. So let's save ourselves a little trouble and say cotangent of x would equal 1. Take the reciprocal. The tangent of x would equal 1. And where does the tangent equal 1? Check your unit circle. That's pi fourths and 5 pi fourths. Okay, so we've got to get it down to a single trig function when this happens. In the book, it typically looks a little bit more like things like 2 sine of theta. Here's one from the book. This is number 29. 2 sine of theta, and it says it equals, 2 sine of theta minus 1 equals the cosecant of theta. And you think, wait, how are sine and cosine related? They're reciprocals. So I'm going to write this 2 sine of theta minus 1 equals 1 over the sine of theta. And that's a messy looking problem. So what you do is you don't like those fractions, so multiply everything, both sides, multiply by the sine of theta. And make sure you distribute. And as you do that, 2 sine of theta times sine of theta is 2 sine squared of theta minus sine of theta. And over here, the sine of thetas cancel out. You get 1. And now proceed. Set it equal to 0. And it becomes just like one of your previous problems. So you set that equal to 0, and you'll factor it. So that's what seems to come up more frequently, is they give you a function, and it's a reciprocal function. And the trick is, put in the reciprocal function, but then you need to multiply. Let's look at just one more like that. I see one here goes tangent minus cotangent equals 0. I'm just going to scoot up again so we have space to see this. And this one you could almost do in your head, but this is number 31. It's the same idea. Tangent minus cotangent equals 0. You know those are reciprocals. So tangent minus 1 over tangent equals 0. So the trick is going to be multiply both sides by the bottom, which is tangent. So multiply both sides by tangent. When you do that, you're going to get tangent squared minus 1, because I'm distributing. Tangent times tangent is tangent squared. Here the tangents cancel out, equals 0. And from there, again, you proceed to solve that problem. Okay, so that's one type of problem. The last type of question, and I want to skip to maybe, they're both the same. Let's skip to this one. The last type of problem is like this. And it goes 2 cosine squared plus 2 cosine x minus 1 equals 0. You look at it, it doesn't look so bad. But if you try to factor it, you can try your AC method if you'd like. And so you multiply the 2, this 2, times this negative 1. And you get negative 2. Try to break up a negative 2 to get a 2 in there. How about negative 2 times 1? How about negative 1 times 2? That's about the only possibilities. None of those, neither of those, add up to 2. So you can't factor this. So instead, what you have to do when you have a problem like this is you have to use your quadratic formula. And so this will come up on your homework. And again, it's expected that you can solve a quadratic equation. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. If you look up at your problem, the coefficient in front of the square, that's your a, that's your b, and that's your c. So let's sub in. Negative b is negative 2 plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, let's simplify a little bit. We get negative 2 plus or minus the square root. And let's see here. Negative 4 times 2 times negative 1. How much is that? That's 8. 4 plus 8 is 12. And I get that all over 4. Okay, at this point, any hope of finding this on your unit circle is pretty much gone. So you might as well bring out your calculator. You can simplify this algebraically, I know that. But let's just use our calculator and get some decimals here. So we'll bring out a calculator. Oops. Let's not cover up the problem. And let's try to figure out what's negative 2. Let's add on the square root of 12. Get that answer. And then divide it by 4. And there's one of our answers. And then let's go negative 2 minus square root of 12. Get that answer? And divide that one by 4 as well. So we've got 0.366 and negative 1.366. So we got x equals 0.366. And in this case, it's not x, is it? Come back up here. It's cosine. Look at that. So our two choices are cosine of x equals 0.366 or cosine of x equals negative 1.366. Okay, and again, like I said, good luck finding that in your unit circle. So instead, you use your calculator. How do I find that angle? Where's the cosine equal? 0.366. And for this problem, let's just try this in degrees. It's a little easier to understand in degrees. So switch our mode. Let's switch down to degrees. And I'm looking for an angle. What do I use? I use the inverse trig function. So I go cosine inverse of 0.366. And it will give me my angle. Oops, one too many parentheses there. Sorry about that. Let's try that again. Cosine inverse of 0.366 is 68.5 degrees. So x equals 68.5 degrees. Okay, we're going to come back to that. Let's just go to the next part here, though. I'm going to close that ink. It does that funny business with me. So 68.5 degrees was this one. Move that up just a little bit. And in the second one, you could try this on your calculator, the cosine inverse of negative 1.366. But you know cosine never gets bigger than 1. It never gets smaller than negative 1. So that one's not going to give you any answers. You can try it if you don't believe me. But that will lead to an error. Okay, come back now to this first answer. 68.5. Think about, so we got that angle here, 68.5 degrees. But think about what other quadrant is the cosine positive? A smart trig class. There should have been another angle down here in the fourth quadrant. And remember your reference angles? Well, 68.5 is your reference angle. How do you get this angle? Let's go 360 minus 68.5. And I just want to double check on my calculator that I didn't copy that answer wrong. It was 68.5, thank goodness. And let's just go 360 minus, since we have it up here now. 360 minus second answer. And I get 291.5. So I get two answers. 68.5 and a 291.5. Because again, I had to consider reference angles. Where's the cosine positive? That's a positive 0.366 in two quadrants. The first quadrant, but don't forget the fourth quadrant. Not an easy problem to do. All right, so this shows you the two types of problems that are the trickiest. First type, when there's multiple trig functions, use an identity, a lot of times it's a reciprocal identity, to get it down to a single trig function. And then the second tricky type is when you can't factor anymore, and it turns out you have to use the quadratic formula. All right, that completes it. That completes Chapter 6, Section 2. So we will stop there, and you guys can get to work.